Hey, grade nines, how's it going? This is the supplement video to the Math Antics video for week two. This is week two in your math lessons, and this video will be linked in your Google Slides. I just wanted to provide some comments here about what our friendly math mentor guy in the Math Antics video said. I just wanted to support what he said and just maybe flesh it out a bit. He talked about that algebra is sort of this little game or science of, or art even, of undoing. So what I've done here is I've made these questions so that you can sort of make a comparison of what goes on with BEDMAS, all right? So this comment's really about BEDMAS. If you have a normal question over here in the purple, so you have a normal BEDMAS questions, this is what he calls do, versus algebra over here, this is undoing, working backwards. So let's say you just have this normal question. Well, so what does BEDMAS say? BEDMAS says this, all right? So you have BEDMAS. And you know the way I like to write it. D and M are the same priority. So I tend to write BEDMAS this way. But regardless, we know for sure that this operation is multiplication. So technically there's brackets, so I guess you could kind of say brackets, but the brackets are really talking about multiplication. There's no exponents. There's no division in this. There's no subtraction. So what have you got? You've got multiplication, you've got addition. You're going to do the multiplication first. You guys know how to do this. So 4 times 2 is 8. And then we've got 8 plus 3. And there you go. It's 11. All right? So what he's saying in the video, though, is when you have algebra, algebra is this art of working backwards, because here, look what you have. Actually, I'm just going to choose a different color here for a sec. Okay, let's just choose blue just for a sec. So you got this unknown. How could you possibly do BEDMAS in a normal order, right? Of going, okay, do I have brackets? Do I have this? Don't have this? You can't follow BEDMAS because you have an unknown. You have the solution, okay? You have the answer. Let's see if I can write that better than I did with solution. So you have the answer, it's 11. So you don't need to worry about BEDMAS working in the typical order. Algebra is the art of working backwards to find your unknown, okay? So let's just erase this a little bit. Gotta be careful because see that? I just obliterated the X a bit. Okay, so you've got the 4x plus 3 is equal to 11, okay? Let's see if I can fix this a bit. So 4x plus 11. Okay, that's about as good as it's going to get fixed. So what are you going to do first? Well, BEDMAS, you have to, this is the art of undoing. So BEDMAS says when you do it in an algebra context, you've got to do, level 1 is to deal with the subtraction and addition first. Then you've got to deal with multiplication and division. And then you're going to deal with exponents. And then you're going to deal with BEDMAS, or pardon me, brackets. So you have to deal with the addition first, okay? So, you know, you guys have done this. You know what to do. You got to subtract 3 from both sides. This cancels that out. And what are you left with? Well, you've got 4x is equal to 8. All right? And so we always want to solve, we want to be left with x equals something. In other words, a positive 1. Okay, a positive 1, which we always leave invisible. It's always better to undo than try to erase. So in other words, we've got to do something with this 4, right? We're going to divide both sides by 4. Away you go. Whatever you do to one side, you must do to the other, because algebra is always about maintaining your balance. So this does reduce to a 1. And 8 divided by 4, of course, is equal to 2. And that's our answer. Whoops, meant to circle this one. And we know that's supposed to be the answer. But the point is, these two things here, they're the total opposite of each other. When you have just a normal question, there's no variables, of course you're going to follow normal BEDMAS order, or normal, what we call GEMS order. And I may talk about GEMS a little bit later. But here we have algebra. Algebra is working backwards. You've got to undo the order of the operations in reverse order. That's why we deal with constants first. Remember the 3 from our polynomials unit? There's no variable here, so it's a constant. You've got to deal with the constants first, whether they're added or subtracted. Doesn't matter how they're written. This could have been easily subtract 3 and then we add 3 to both sides. Doesn't matter. The point is, this is a constant. We deal with it first because its operation, this 3, is attached operationally speaking with addition and subtraction. Well, in this case, it's addition. So we deal with the 4 last. We deal with addition first, then the multiplication. And we're always working in opposite operations. So how did we solve this? We subtracted 3 from both sides, then we divided both sides by 4. Okay, enough of that. Next one. Okay, now, all I want to point out here is there's really not a lot of difference between this question and this question. The only difference is this has nice whole numbers, and therefore I can solve this with mental math. If you like my quotes. So a lot of students really like to rely on it, and it's really kind of a crutch, grade 9s. You're relying too much on your questions being easy from a mental math point of view. Everybody knows that 4 times 2 is 8 plus 3. That's equal to 11. You can do that in like 10 seconds or less. Now, you can't do this, but it's not a scary question. Structurally speaking, it's the exact same question as this. In other words, there's a part of this 2-step equation that's multiplying, and then we add it. Over here, there's a part here that's multiplied. And yeah, now we're not adding, we're subtracting, but it's structurally the same. There's 2 steps involved. This is still a 2-step equation. Don't think this is harder just because you can't do 4.1 times 2.3 necessarily in your head. Even I have to think about that for a minute. Or I'm just going to get a calculator, right? So don't think this is harder, all right? Structurally speaking, it's still a 2-step equation, and you can do it. So actually, I'm going to take my handy-dandy calculator, and I'm going to do this 1 step at a time. We're following normal BEDMAS here. So where's my D? There we go. Okay. So the brackets are kind of fake. They're really meant to imply multiplication. There's no exponents. There's no division. There's no addition. We've got subtraction. So we're doing multiplying and subtraction as part of our 2 steps. Okay, let's get doing this. So 4.1. Now I'm looking down at my calculator. Okay, 4.1 times 2.3 is equal to, so this is equal to 9.43, right? It's tough to read my calculator. I'm filming this at night. So then we're going to subtract 6.9. So 9.43 minus 6.9, and we get an answer of 2.53. And I should have really realized that because I asked the exact same question over here. I already know the answer, right? So again, though, what is algebra? Algebra is the art and science and magic and beauty of working backwards. We're going to undo this. So we have to deal, operationally speaking, we have to deal with addition and subtraction first. Then we'll deal with any multiplication or division. Then we'll deal with exponents. And then we'll deal with brackets. Now, I'm going to tell you something, a little heads up. In high school, it may be not quite this simple, but frankly, I'm going to leave it to your high school math experience to see how this might need to get adjusted a little bit. For the purposes of grade 9, essentially algebra is undoing. We're doing BEDMAS in a backwards order because we have a variable. This is not the same type of question as this one is. This one's seeking the answer. We don't know the answer. Here we have the answer. We have to work backwards. Okay, so I think by now you can anticipate what's coming. What's the opposite of subtraction? It's addition. So we're going to add 6.9 to both sides. Add 6.9. Do your best to line up the decimals. Okay, so then you have 4.1g. And this is equal to 9.43, as it should, because guess what? That's what it was over here, right? And now you're going to divide both sides by 4.1. And what is that? So look, we're still dividing by whatever the coefficient, 4.1 is the coefficient of g. We're dividing 4.1 by 4.1 because what will happen? We're left with a positive 1g. The positive 1 is always left invisible. So in other words, we're just left with g. That's it. All right, and 9.43 divided by 4.1, well, it should be 2.3. But for kicks and giggles, I will check it on the calculator, even though I really don't have to, but some of you like to see the magic. I don't know if you can see that. Can you see that? Yeah, I guess you can a little bit. I choose not to shine it into the light. Okay, so that's that. All I'm trying to prove to you is, okay, so there's decimals. How scary are decimals to you? Really, this is psychological. I don't think this is any more difficult than the whole number question. Okay, and we're back. Little technical glitching there. All right, now I got fractions. Again, just a comment here. We're dealing with fractions. You could have fractions in the answer, right? What is the expectation for grade 9? At grade 9 level, we're getting to the point where it shouldn't bother you no matter what parts or components are in the algebra. It shouldn't matter if they're whole numbers, whole coefficients, whole constants, whole solutions, or if they're decimals, or if they're fractions. So my comment here is we could have fractions in the answer like we do here. We could have it fractions in the constant or the coefficient. Well, lucky us, we only have a nice whole number of 2 to deal with, or any combo of them. So in this case, we have a fractional answer and a fractional coefficient. Guess what? Same procedure. This is still a 2-step equation. I get the fact that fractions in and of themselves may involve a little bit more work because there could be common denominators involved and all that stuff. But nevertheless, it's still, structurally speaking, it's still the same question. It's still 2 steps. So what do I got to do to both sides? Well, we got to add 1/10. Whoops. No, we don't. Bad, Mr. Smith. Let's try that again. We're already adding 1/10. So why don't we try subtracting 1/10? Let's subtract 1/10. That would be better. Because look, if you have positive 1/10, minus 1/10, in other words, you've just zero paired this out, which is a good thing. And so what are you left with on the left side? You've got 2x. Now over here, yeah, like on the side, a little bit of a scratch pad moment for you. You've got 3/5 minus 1/10. Okay, maybe not quite as straightforward as whole numbers or decimals. In other words, we've got a little bit of extra work to do. It's not a big deal. But this is also why your grade 9 teachers, whether it's me or Miss Schreiner or whoever you have for grade 9, we beg you to become little masters of fractions in grade 7, 8, even grade 6, 7, and 8. Because you don't want to stumble at this step. The algebra is the grade 9 part of the question. It's expected that you are not thrown off by doing a relatively straightforward fraction subtraction question. So we need a common denominator here. So we need a lowest common denominator. Between 5 and 10, our LCD is equal to 10. Okay? Just in case you're wondering, why am I multiplying this fraction by 2? Because I'm creating equivalence here. I'm converting 3/5 into 6/10. It's the exact same thing. If we talk to this in terms of what it's a decimal, it would be 0.6, 0.6, or in percents, this would be 60%, this would be 60%. What's the advantage here? The advantage here is same denominator. Now we can do 6 minus 1 all over a common denominator. I think by now you guys know this is my absolute favorite step when it comes to adding, subtracting fractions. You're telling me that there's only a single common denominator in this step, and you only do the operation of subtraction. It only applies to the numerators. So we've got 5/10. Now, some of you might be really on the ball here and say, Mr. Smith, we've got 5/10. Can we reduce that right now? And my answer is yes. Absolutely go ahead and reduce this to 1/2. So in other words, we have 3/5 minus 1/10, and that was equal to 1/2. Okay? 1/2. All right. At some point, some students are tempted to convert this question into, Mr. Smith, can I just do this as 0.5? In other words, they want to live in decimal land. Yeah, if you want to, but I'm going to carry on in fractions because that's the way it was originally written. So you've got 2 multiplied to x. 2 multiplied to x. Let's go with, let's go with blue. Okay. So 2 multiplied to x. Well, why don't we divide both sides by 2? Okay. Now over here, I'm going to write it. This is one of the few times where writing a division sign might be kind of handy, because I've already got a fraction over here. I don't want to write 1/2 over 2. I mean, that gets, for some students, that looks a little crazy to them. So why not use the division sign? All right. So this reduces to an x, and we've got 1/2. And again, grade 8. You know darn well that we don't divide fractions, and grade 8 gets into the whole exploration of why, so I'm not going to cover that right now. But it's essentially we invert the operation, which means we need to invert or reciprocate this number. So 2 is the same as 2 over 1. So when we flip 2 over 1, it becomes 1/2. And x is equal to 1 times 1. Remember, with multiplying fractions, you just go ahead and multiply the numerator times numerator, denominator times denominator, and we get an answer of 1/4. Okay? We get an answer of 1/4. All right? So, yeah, I would agree. A little bit more work perhaps involved in when you have fractions in your algebra. But please do not adopt this mindset of they're crazy difficult. They're just more work. That's what I'm fond of saying, and you guys know that. Okay, so the last example I'm going to do tonight is from page 306. These are some of the demonstration examples, and so I thought I'd go through them as well. So I was talking earlier about, now in grade 9, you're expected to deal with fractions anywhere in your question. So in this case, we kind of got a triple header. We've got a fraction that is attached to the variable, or you could, some are going to think of this as k divided by 3, which is correct. We've got a fraction in the constant, and we got a fraction in the answer. Okay, first thing, okay, no mixed numbers. All right. So you want to get rid of this. Now, some students are tempted to convert this all to decimals. Okay, it's not a bad strategy, except this one here, that would be a repeating decimal. I'm not a big fan of it, so I would just deal with it from this point of view. Okay. Now later on, I'm going to teach you a little bit of a neat trick to deal with the fractions all at once. But I'm not going to do that trick for this question, okay? We're just going to do this question as normal. By the way, just over here, just so you get understanding of like math grammar or math writing styles, this question could be written as like this. Just so you know, this first part could be written as 1/3 k. In other words, the k is just hanging out by, it's no different, like say if it was like 4x, the number of the coefficients in front. You could say that this divided by 3 is the same as 1/3 k. In other words, the division is written as sort of a multiplication statement. And then the rest of the question is the exact same, okay? So I'm simply saying to you, when you have a variable divided by a number, it's the same as that number being 1 over itself, written as a fraction, to be written as multiplication. But anyways, that's just a little side note. What are we going to do? Well, again, what do we have for, remember algebra, we're supposed to undo this. So actually we're supposed to start here, and we have subtraction. So we don't have addition. We got to deal with subtraction first. And then what do we have? Well, we have a division, so we don't have multiplication. This will be second. And there's no exponents, and there's no brackets. So we're going to deal with the subtraction first. The opposite of subtraction. Remember, we want to zero pair this out. This would be no different if you had, yada, yada, yada plus 3, and then you're going to take away 3 from both sides. Or you had yada, yada, yada minus 4, and now you're going to add 4 to both sides. Okay? So the point is to get, when you have addition and subtraction, you want to zero pair them out. So we're going to add a half to both sides. Okay? We're going to add half to both sides. Minus a half, plus a half, well, see you later, alligator. That was the whole point of doing that, so that this is gone. And then to maintain balance, whatever you do to one side, you do to the other. What are we left with on the left side? K over 3. All right, and we've got negative 7 fourths plus 1/2. Okay, again, not to get to go off too much on a tangent like Mr. Smith is famous for, but we're going to immediately create a common denominator here, okay? So back to blue. What have we got off the left? Well, we didn't touch the left, so the left stays the same. We've got negative 7 over 4 plus our newly converted equivalent fraction. What's the same as 1/2? 2 over 4. Now we've got a lovely common denominator situation here. Perfect. So I'm going to carry on over here before I run out of paper. K over 3. Whoops, that's not a very nice looking 3. Just bear with me for a sec. Okay, K over 3 is equal to negative 7 over, plus 2 over 4. Okay, so K over 3. What is negative 7 plus 2? Well, it's negative 5 over 4. Okay, now we've got something that's maybe a little bit more workable. Certainly, I'm at a stage where this is kind of one of my favorite types of problems to tackle, because it immediately suggested to itself that perhaps we could do a little bit of cross multiplying here. And yes, you could just, I suppose you could just multiply both sides by 3. So some of you might say, Mr. Smith, can we not just multiply both sides by 3? So let's actually do that. Sometimes I'm such a fan of cross multiplying, I do it even maybe when it's quicker to just, multiply by the number that's being divided. It's K divided by 3. Why not just multiply both sides by 3? Because the 3's will not cancel each other to 0, but they'll reduce to a 1. Okay? Don't think that 3 over 3 is 0. It's not. We know that 3 over 3 is 1. 3 over 3 is equal to 1. So in other words, we're left with 1K here. Now, 3 is the same as 3 over 1. We're multiplying these fractions. K is equal to negative 15 over 4. Yeah, and yes, by the way, if I cross-multiplied these things, if I cross-multiplied this relationship, I would have got the same answer. But maybe in the end, it would just been easier to just work our way backwards, do the undo. What's the opposite of division? It's multiplying. Multiply both sides by 3. Okay, that's it for the supplement video to help support what our friend was saying in Math Antics. Hopefully this helped you a little bit. Work your way slowly through this. Don't try to rush it. And just this is an important section. And it's an important section in terms of you need to get really good at this for high school. So take your time. I know that fractions and decimals appear not to be as easy as whole numbers, but with practice, that's the key. With practice, you'll get it. Okay. All right. Take care, everybody. Have a good night. We'll see you next time.